Okay. So where this becomes useful is when we have to integrate something and we've got a rational expression and a u substitution doesn't work. Okay? To do the little proof part that we have to do in our notes tomorrow, okay, we have to be able to do a partial fraction decomposition. It doesn't come up in integration other than that until we hit chapter 8. Chapter 8 is more integration. It just gives us some other more advanced techniques in integration. Okay? That's kind of what we're leading into. That's why it's right before the chapter. Well, it's actually before the chapter 7 stuff, isn't it? So it should have been kind of in here a couple pages sooner. All right, so it is section 7.3 from your pre-calc. We did this when we were doing systems of equations because we use systems of equations to solve a partial fraction. Okay? So we are supposed to write the partial fraction decomposition for the rational expression. So the first thing we do when we do this is we have to factor the denominator. And I know it's been a couple years, that's why we're spending the whole day going through this. So you tell me, what does this factor into? X plus 2, x minus 3. Do we all agree with that? Yeah. Okay. So what we do with this, and this should be familiar once we start doing it, okay? We put x plus 2 under one and x minus 3 under the other. And then I need to figure out how this x plus 7 breaks up. So right now I put an a and a b on the top. Okay. The next thing I'm going to do is I'm going to multiply everything by that denominator. Okay. So I'm going to multiply everything by x plus 2 times x minus 3. X plus 2 times x minus 3. And x plus 2 times x minus 3. Now, I'm doing it the long way. I'd probably take some shortcuts on this because there's some obvious things that are going to cancel. We're doing this on purpose because we're going to try to get rid of the fractions right now. Okay? Temporarily. We're going to bring them back at the end, but temporarily. So, obviously, everything here would cancel and I'd be left with x plus 7. Okay? What would cancel in this one here? X plus 2, and I'm going to distribute a in. So we'd have ax minus 3a. All right, what's going to cancel in this one here? X minus 3. What's wrong? I distributed in. Okay. All right, and so I'm going to distribute the b in, so we get plus bx plus 2b. All right. Now we're going to ignore the x's and set up a system of equation to solve for the a and the b. So I have to write an x equation. So I've got a 1, an a, and a b. Everybody see where I'm highlighting and what I'm going to set up here? So I'm going to set up an equation that says 1 equals a plus b. Okay. And then I'm going to set up another equation. Let's see if I can find another color here. I've got this. Oh, that didn't do well, did it? That was a bad choice, wasn't it? Ooh, we need something that we can see through. Let's see. Let's see if we could try that green and see if that's better. Can't even see it. Oh, that's the pen, not the highlighter. Ink color. Switch to that one. Better. 7, the -3, and the 2. Okay, I know it's still hard to read, but it's better than it was. All right, so we're going to have our second equation is 7 equals -3a. Sorry, it should be -3a. Keep the a there with it, plus 2b. I didn't highlight enough. So it should be this whole thing and this whole thing. All right, now that I have a system, we're going to use our systems of equations techniques. Either we can use elimination or we can use substitution. I'd probably use substitution because this is just a plus b, right? So which one do we want to solve for, a or b? B? Okay, so we're going to do 1 minus a equals b. And then we're going to go ahead and take this and plop it in for the b. So we've got 7 equals -3a plus 2 times 1 minus a. Hopefully systems of equations is very familiar. We didn't do it a whole lot in calculus last year. We didn't probably do it a whole lot in math analysis, but you did it in algebra 1 for sure. Okay, what are we going to do with that 2? Distribute. Systems comes up in very interesting places, so it's a really good algebra skill to have. And it doesn't look like a traditional like linear system, most of the stuff we end up doing. All right, what's wrong?
Do we get 1 minus A?
Do we get what?
How do we get 1 minus A?
1 minus A. I took this A and I moved it to the other side when I solved for B. Okay, Cody? Yes? No?
Why do we solve for B?
Why do we solve for B? Because we just chose to solve for B because that's what Joaquin told me to do. He said to solve for B, so I solved B. Did I have to solve for B? No, I could have solved for A. I could have done it by elimination. Okay? So solve a system using your system techniques is what we're doing. Okay? All right, what am I going to do with that 7? Or sorry, with the 2? Subtract it from 7, what do we get? 5. And then we've got -3 and -2 is what? -5A. So what's A going to equal? -1. Yes, you got to plug, because we have to, our goal is to solve for these numerators here. Okay, that's our goal in this. So we're going to plug it back into, I'm going to put it back into that one. So I've got 1 minus -1 equals B. So what's B equal to? 2. Positive 2. All right, so now what I'm going to do is I'm going to rewrite these fractions that I had, pretend we didn't cancel them. Okay, what am I going to plop back in there for the A? -1 over x plus 2. And what am I going to plop in for the B? 2 over x minus 3. So here's where this comes in for calculus. Compare what we had originally to this. I couldn't integrate that originally, right? Because even if I did a u, I'd have x squared, 2x minus 1 for the derivative. It's not there. But when I did the partial fraction decomposition, these are nice integrations. They're lateral logs, right? When we go to integrate those. So that's kind of where we're going to eventually go with it. And unfortunately, we have to do one of those integrations in the notes for the logistics. So that's what that's what we'll do tomorrow. Okay? All right, so we're just practicing this one algebra skill today. So let's try it again. Okay? Let's see what this one looks like. Okay. All right, we're going to do this one again together, and then I'll have you do the last one on your own. All right? So you tell me, what does this factor into? X plus 4, x plus 2. Good. And again, I'm probably not going to write down as much so we don't get too much up there. We have x plus 2 in this denominator, x plus, oh, sorry, does it matter? We did the 4 first, right? Does it matter the order I do, do those in? No. Okay. All right, this is A, this is B. Now, we know that something's going to cancel, don't we? Do I really need to write down x plus 4 times x plus 2 on all of them? No, you're in Calculus BC. Okay, we can take some shortcuts. I know that this is going to all cancel. I'm just going to write down x plus 8. Okay, I'm going to switch to a different color. You can kind of see some of the work here. All right, I know that the x plus 4 is going to cancel, so basically I multiply by the opposite one, right? X plus 2. So what do I get when I distribute that? Good. And then I would multiply again by the opposite one because I would end up canceling the x plus 2. So I multiply by x plus 4 and we distribute. What do we get? Bx plus 4. Sorry, 4b. All right, now we have to set up an x equation, an x coefficient equation, and a constant equation. Okay? So what is my x coefficient equation going to look like?
1 equals A plus B.
Good. That's right. 1 equals A plus B. All right. Yes, Joaquin. All of these, see how I underlined in 1? All of those had x's. Okay, does that make sense? All the other ones, if I had, sometimes I have 3, although we only do linear. We don't do we do linear non-repeating is what we typically do in this class. We do it could be a squared, an x, and a constant, so you might have 3 equations because we do a system of 3. Okay. All right. What's my other equation going to be? 2a plus 4b. Okay, let's do elimination this time instead of substitution. Okay, we might like elimination better. If I'm going to do elimination, do you want to eliminate the A or the B? A. Okay, so what am I going to multiply this top one by? And again, it doesn't matter which type of system method you use. Okay? If you like Kramer's rule and you want to use Kramer's rule, go for it. Okay? It's the one with the determinants. Okay? All right. You can take a whole class in that in college. It's called linear algebra. It's awesome. It's the best math class ever. All right. What's 8 minus 2? 6. All right. The A's are gone. 4B minus 2B. 2B. And divide by 2, what do we end up with? 3. Okay, so I still got to solve for A. I'm going to choose to go into this top one here. So 1 equals A plus 3. So A is equal to what? -2? Everybody okay with that? Because I heard like 4 different answers. Okay. Now I've got to kind of come back up here. And I'm going to plop the A and the B in there. So I'd have -2 over x plus 4 plus 3 over x plus 2. And again, those don't matter, but the number on top should match what's on the bottom. Okay? You can't reverse the 2 where the 2 and the 3 are without the correct denominator.
So we use this answer when the use substitution doesn't work when you integrate?
When that's going to be one of the uses for it. Yeah. Yeah. What's wrong?
Two questions. Why is A plus B equal 1?
A plus, okay, so A plus B equals 1 because I'm looking at 1, A, and B, and writing an equation from that, a coefficient equation.
Okay.
Okay, and then the other question would be where's the other one is the ones without the x's on it. Okay?
Why'd you multiply by -2?
Why did I multiply by -2? Because I'm solving a system and I chose to do elimination this time. So to do elimination, you need to get a same coefficient but with opposite signs. Okay? Okay.
Why is it easy?
Why what?
Why is it easy?
Why is it easy?
Yeah, because we're in calculus BC and I think easy there.
You think this is easy?
Yeah.
Good. That'll
That's
make
a bad
tomorrow's
thing.
that'll make tomorrow a little bit easier.
Easy on the homework. That's the problem.
We're putting this on the homework, yeah.
You gonna change it or?
Am I gonna change it
Yeah,
today?
you usually do that. You make it hard on the homework.
I don't know. I didn't look at the book problems, but all right. Am I gonna change it?
She's like
Okay. Here's what I want you to do. Well, actually, you know what? I'm gonna start it with you. I didn't look ahead far enough because there's a little bit of a catch on this one. All right. So you tell me, what does the denominator factor into?
Don't you got the 4?
2x minus 3.
2x minus 3. 2x plus 3. Okay. So we know we've got 2x minus 3 and then plus 2x plus 3, and I've got an A and a B. I'm going to get you to the point where we set up the two equations, and then I'm going to have you finish it from there. Okay? Okay, so we know that when I multiply by the least common denominator, I'm going to just have a 1, right? And leave some space there. What would I multiply this one by? Because I know the 2x minus 3 is going to cancel. 2x plus 3, and I'm going to distribute the a through, so I get 2ax plus 3a. So again, I multiplied by the opposite of the denominator. Here I'm multiplying by the one that's missing in the denominator. So we get 2bx minus 3b. Now let's set up an equation. Notice over here there are 0 x's. Okay, so now let's set up that coefficient equation. So if I'm going to set up my x equation, what's my x equation going to be? Plus 2b. Okay, and then my constant equation is going to be what? All right, from there it's a systems of equations. So I want everybody to try to finish it from there. Take a minute, see if you can solve the system, and then get the fractions written again. let's see where we're at. So what do you guys want to do? Substitution, elimination? Elimination. What are we going to eliminate? The A or the B? The B. So we're going to have to multiply them both, aren't we? Okay, so we multiply the top one by what? 3 and the bottom one by 2. So 0 equals 6A plus 6B. And 2 equals 6A minus 6B. Alright, and then 0 plus 2 is 2 equals what? Oh, we got fractions, didn't we? Alright, so what did we end up with for our A? 1/6. Okay. And then what did we end up with for our B? Yeah, negative. So if I sub back into this top one here, 0 equals 2 times 1/6 plus 2B. So let's see. Huh? That's fine. Depends on where you want to do it. I'm going to just go ahead and subtract 2/6 to the other side. And then we divide by 2 or multiply by 1/2, so they cancel, don't they? So negative 1/6. So when you rewrote this, it looked weird, didn't it? So I'll show you how to fix it up. So you got 1/6 over 2x minus 3 plus negative 1/6 over 2x plus 3. That looks awful though, doesn't it? Couldn't I factor out a 1/6? So, were you right, Joaquin?
Oh, no, I just calculated.
Used what?
I miscalculated. I put 6 instead of 1.
Oh, okay. All right. We good? Okay, so the homework is right below. We're not going to do all of those, though.